Good day everyone, and welcome to the BTech Quality Stats for Class project. This is a group presentation on the subject matter titled Measures of Dispersion. On our contents today, we are going to be discussing the background and introduction to measures of dispersion, the characteristics of an ideal measure of dispersion, the types of measures of dispersion, the classification of measures of dispersion in statistics, examples to explain the subject further, as well as conclusions. On the background and introduction, what are measures of dispersion? We have said that measures of dispersion refers to the extent to which the data values of a numeric random variable are scattered about their central location value. Also in statistics, dispersion, also called variability, scatter or spread, is the extent to which a distribution is stretched or squeezed. Common examples of measures of statistical dispersion are variance, standard deviation, and range. It describes how spread out a set of data is. For instance, when a data has a large number or large value, the values in the set are widely scattered. Similarly, when it is small, the items in the set are tight. The main characteristics of an ideal measure of dispersion are as follows. We have identified a total of 5. The first one is that it should be rigidly defined. It should be based on all the items. It should not be unduly affected by extreme items, such as outliers, also known as outliers. It should lend itself for algebraic manipulation. And lastly, it should be simple enough to understand and easy to calculate. Types of measures of dispersion. So we've classified measures of dispersion into 2 categories, which are algebraic and graphical measures. For our presentation, we're going to be talking about algebraic measures. So algebraic measures are subdivided into relative measures and absolute measures, as you can see these two. Both these subdivisions are further divided into 4 groups, each which are the range, the mean deviation, the quartile, the standard deviation, and then for the relative measures, these are the coefficients of all of the above. But as I've mentioned, that our presentation is going to be based solely on these 4, which are your absolute measures. So as previously mentioned, the first one that we will consider in our explanation is the range. What is range? If somebody will ask, we have defined it as range is the difference between the highest and the lowest data values in a set. There is a simple formula that is used to calculate range, where you have R is equal to X max minus X min, where R is the range and X is the data value. The primary advantage of this measure of dispersion is that it is relatively easy to calculate. An example of a range, we have said that we've given a set of scores of 10 boys in a test. We have 17, 23, 30, 46, 45, 51, 58, 66, 72, and 77. So then to calculate the range, we will need the difference between these 2 scores, because 77 is of course our highest and 17 is our lowest, which gives us a total of 60. Similarly, the scores of 10 girls in a test are 48, 49, 51, 52, 55, 57, 50, 59, 61, 62, and therefore the range will be 62 as the largest value minus 48, which is the smallest, which gives us a total of 14. So here we find that the scores of the boys are widely scattered, hence we have a bigger number. Thus the scores of boys vary much, but the scores of girls do not vary as much. Of course, they vary less. Thus the variability of the scores of the boys is more than the variability of the scores of girls. Now on to classification of absolute measures, the second bullet point. We will be talking about the mean deviation. The mean deviations may be defined as the average of the absolute values of deviations from the mean, median, or mode. It takes into account the differences between each value in a set of values or in a set of data and the average of all the values of that data set. Now there is a simple formula to calculate that, and that is what is highlighted there, where that summation represents the sum of all of your values, where X represents the observation, mu of course is your mean, divided by N, which is the number of observations you are dealing with. So a mean deviation is the simplest measure of dispersion that takes into account all of the values in a given distribution. It is very easily comprehensible because even a person who is not very well versed in statistics can use it. It is not very much affected by the values of extreme extreme items or outliers. It is the average of the deviations of individual scores away from the mean. Now onto an example of how we can calculate our mean deviation. We are given a question that says, in a group of 8 auditors with a monthly target of 18 audit reports, the following submissions were made. We have Monica submitting 12, Mihle submitted 14, Steve submitted 20, Loyola submitted 24, Carola 26, Rosa submitted 8, Laura submitted 16, and Cyril, not Ramaphosa, submitted 24. So if we look at that, then that means we need to determine our n, which is equal to 8. And the sum of all of our items gives us 144. To calculate the mean, as we all know, we will need to take that total divided by the number of items, which gives us a mean value of 18. But onto the calculation of how we get a mean deviation. We have found an image, which of course is sourced from that website that you can see over there for references. And just to give credit, finding the mean deviation is, as we've explained, we will take the value of the data set that we have, each one of them, subtract the mean from it, and we get our value. Now for these ones in the middle column, you'll notice that there's some with negative signs, and that is purely because our value, x, is smaller than what our mean is, which, if you remember correctly, was 18 from the previous slide. So then, because we are working with absolute numbers, we convert those to make them positives. Just fix our screen. Okay, great. So then therefore our mean deviation is the addition of all of our mean deviation values that we've calculated now from subtracting the mean from our values divided by the total number of 8, which then means that our mean deviation will be 44 divided by 8, which gives us 5.5. Now on to the next measure of dispersion, we are going to be talking about the quartile deviation. The quartile deviation, if you just follow there is an image, of course, which gives us the formula of how we can calculate that. This was gracefully sourced from that website over there. You can always check it out just to confirm that our information is correct. The formula to calculate the quartile deviation is QD is equal to Q3 minus Q1 divided by 2. And then back onto our main screen, just adjust it a little bit more. So onto the definitions of a quartile. This is also known as an interquartile range. Interquartile range is defined as the difference between the 25th and the 75th percentile, also called the first and the third quartile. Hence, the interquartile range describes the middle, i.e. 50% of all observations. Now, of course, to further explain the example, we have a question that says below, consider the marks of the 100 students below, which have been ordered from the lowest to the highest score. As you'll notice, the first student scored 35, and the last one, which is the highest, scored a number of 85. The quartile tells us about the spread of your data set by dividing the data set into quarters, just like the median divides it into half. The first quartile, Q1, lies between the 25th and the 26th value, and then the second quartile lies between the 50th as well as the 51st value, or the 51st student's mark, and then the third quartile, Q3, lies between the 75th as well as the 76th student's mark. And how we calculate that then in the above example, we have an even number of scores, which is 100 students rather than an odd number. This means that when we calculate the quartile, we take the sum of the two scores around each quartile and then halve them. Hence we have added Q1, 45 plus 45 divided by 2, which gives us a total of 45, of course. However, if we had an odd number of scores, say 99 students, we would only need to take one score for each quartile, that is the 25th, the 50th, and the 75th score. It is important to recognize that the second quartile is also known as the median. So therefore, our quartile deviation for this sum would be QD is equal to Q3 minus Q1 divided by 2, which is your 71 over there, minus 45 divided by 2, which gives us a total of 26. And on to our our very last measure of dispersion, which is titled standard deviation. Here again, you will remember that we had an image sourced from that website over there, which is your normal Z table. which has the characteristics of the bell shape and the normal distribution curve, where we know that the observations of all of the values, which is 1 standard deviation away from the mean on both sides, will give you 68.2. 2 standard deviations on both sides is 95.4, and 3 standard deviations on both sides of the mean will give you a total of 99.7. So standard deviation described or explained, we've said that this is the square root of the sum of squared deviations from the mean divided by the number of observations, where we have a simple formula. Again, that just talks about the summation of all of your values. X represents the observation, X bar is your mean, of course, N is the number of observations you're working with, and the sign is the square root of all of that. So this is known as the measure of spread of data around the mean. The more widely spread the values are spread out, the larger the number the standard deviation will be. So to further explain this one, also we have the example, which is similar to what we've used before. This time, however, we're only going to be focusing on 5, so therefore that means our N will be equal to 5. We then need to determine the average of the samples, X bar, and how we calculate that is we add all of those 5 values together and divide them by 5, because there's 5 of them, which then gives us the average, which is 37.2. So what we need to do then is to determine the differences between each of all the 5 dataset values here, between them and the mean that we've just calculated. The answer, of course, is divided by 5 minus 1, which is n minus 1, which gives us a 4, and our final answer is 2.2. Now it's important to remember that this 2.2 is your sample variance, and we are looking for the standard deviation. Now the standard deviation then is the square root of that sample variance, which will be a total of 1.4832. So therefore then, in conclusion, we can conclude that measures of dispersion speak of the reliability or the dependability of the average values of a series. In essence, performing such statistical measures will be beneficial in determining the nature of your data. So the final points to just remember is that we've said measures of dispersion points out as to how far an average is representative of the target. It determines the nature and the cause of variation in order to control the variation itself. It enables a comparison to be made between 2 or more series with regards to their variability. Of course, this we've seen in the examples that we've calculated earlier, from the range, the quartile deviation, and the standard deviation as well. So measures of dispersion, we've said, facilitating making further statistical analysis of the series through devices such as coefficient of skewness, coefficient of correlation, variance analysis, and so on. What's important to remember is that the same set of data can be used to calculate any one of these measures of dispersion as we've discussed it above. We would like to take the credit, of course, but that would just be unethical, and it would not be the way that our brilliant lecturer has taught us in the past. So therefore, we've put together a list of about 5 of them, with, of course, their website links that a person can just browse through in their own time, just to confirm that we are not as clever as we'd like to believe that we are, or we'd like to pretend that we are. But we do have our brilliant lecturer as our first one up there, with regards to the notes that she has compiled for the group and for the team. Without her help, we would not have been able to get to where we are right now. So that is it from us. That is the presentation. Thank you very much for your time and your attention. Our group name, of course, is the Hood team, which is made up of the following members: myself, Baziswata Lesile as the presenter. We have Sisonke Tumalisile, Masonabe Matikane, also known as Mason, Amanda Ngwenya, also known fondly to us as Anish, Meba Mapulu, as well as Akona Mache. Now, as a slogan for the 2018 class, our presentation would not be complete without ending it off with one of our lecturer's most favorite lines, in making sure that we are not illegitimate children, but we belong and we have an inheritance somewhere, which is written out for all of us. So that one, to end our presentation off, is the true fact that Bob, of course, is your uncle. Thank you very much. I appreciate all your time and your attention. Have a good day further.